Hello, my name is Henry Pazaryna, and this is my Unit 6 network graph analysis. I'll be reviewing two client networks, assessing their fragility, and then providing recommendations. But before we analyze the client systems, I wanted to share the small example network given to us in the instructions of this assignment. This model helped us practice mapping techniques, confirm that the Tableau setup was correct for our analysis, and then establish a baseline before evaluating two client data sets. With that in mind, let's change from network one, our example, to network two, the first client system. As you can see, this network is immediately recognizable as extremely dense. And from a cybersecurity perspective, the structure is high risk. If a single device becomes infected with malware, the lack of boundaries allow it to spread quickly across the system. And although the network is robust to outages, as removing one device does not break communication, it is too fragile from a lateral movement standpoint. And then to support this analysis, one can add two interactive filters. The first is a wildcard relationship filter, allowing a user to type in any name right here and then instantly highlighting all related communications paths. The other one I'll suggest is a between this filter. This can share any isolation of higher risk nodes that act as bridges or potential spread vectors, both of which I will not share for the sake of time in this video. But based on this structure, my recommendation for this is segmentation. We need to break this mesh into clear groups and reduce unnecessary communication paths. Network three, however, is structured very differently. And here we can see clustering and manageable number of edges. This build is creating a more resilient system where malware spread is slower and more contained. Once again, you can use the same filters, either a wildcard relationship filter using this table here, relationship, or between this slider that can isolate any high risk nodes or any kind of spread vectors. Based on my opinion, no major structural changes are necessary here. I believe that routine monitoring of this system is sufficient and that you don't need to make grand updates. In comparing both networks, though, this difference is dramatic. Network two, it was just unstructured and highly vulnerable. And network three, it's segmented, balanced, and just more secure. Network two required structural remediation, and the network three reflected well designed communication network. And these assessments are based on core graph analytics principles of connectivity density, between the centrality, cluster structure, lateral movement potential, and even network segmentation. So, in summary, network two has too flat a structure and an overwhelming number of edges that create an ideal environment for rapid spread and requires structural remediation and mass segmentation. And then network three, the segmentation and moderate centrality represent a stable and secure communication network with no suggested updates. Thank you.